Welcome, ladies and gentlemen. Today we're going to talk about simplifying radicals. All right, you're going to need your notes, that foldable that we were working with the other day. You're going to need your calculator, and you're going to need your yellow perfect roots table that we completed in class the other day. That's going to be very important. That's going to help us out a lot. All right, let's get started. So this is the foldable that we're going to be working with. Today we're going to be talking about simplifying radicals. So we're going to be working in that section today. When you open up your foldable, it should look like this. You should be able to read the word simplifying radicals on that bottom part. I would like you guys to put in two titles for me. I would like you guys to put in examples without variables on the top, and I need you to put in a title for the bottom part. It's going to be examples with variables. And we're going to be assuming they are positive. So that's very important. I need you guys to put both those labels on there. We're going to do 4 examples in each section, okay? So we're going to have 4 examples without variables and then 4 examples with variables. All right, let's get started. Here's your perfect roots table that you will need to have out. It will be very, very helpful for you. Promise, promise, promise. Okay, here it comes. Example number 1 and number 2. This is simplifying without variables. So this is going to go up on top. Now we've done this back in geometry, you've done this in Algebra 1, and it's coming back to us in Algebra 2. We need to break this down. Since this is a square root, we're going to be looking at our yellow table under our perfect squares. We need to find the largest perfect square that goes into 40. Well, if we break this down, the perfect square that goes into 40 is 4, and 4 times 10 is 40. So we're just breaking 40 apart into one perfect square and one non-perfect square. Now the square root of 4 is 2. Since we can't break down the square root of 10, we're going to leave it as the square root of 10. And that, ladies and gentlemen, is going to be our answer. Okay? Now if we come over here to example number 2, now we're talking about cube roots. So we're going to look under our perfect cubes on our yellow table. Now if we look through, the largest perfect cube that goes into 40 is 8. So we're going to break this apart. We're going to take the cube root of 8 times the cube root of 5, because 8 times 5 is 40, so we're just separating it. And the cube root of 8, if we go across, is 2 times the cube root of 5. We can't break down the cube root of 5, so we'll leave it just like that. All right, there's our first 2 examples. We have 2 more coming without variables. All right, so example number 3 and 4 that need to go on the top. The cube root of 72, so we're going to break this down. The largest, that's important, the largest perfect cube that can go into 72 is 8. So I have the cube root of 8 times 8 times 9 is 72. So the cube root of 8 is 2. We can't break this down, so we're just going to bring it down, the cube root of 9. And that, ladies and gentlemen, is going to be our answer. Alright, we're going to do the same thing with our last example without variables. Now we're talking about fourth root. So we go to the 4th power on our yellow perfect roots table, and the largest perfect 4th power that goes into this is 256. So we're going to take the 4th power of 256 times the 4th power of 2. Now the 4th power of 256 is 4. So I get 4 times the 4th power of 2, 4th root of 2. And that right there is our answers, ladies and gentlemen. All right, now we're going to be moving on to examples with variables. Now we're going to assume that our variables are always going to be positive when we're doing this, all right? So when we do this, we're going to take this first example, we're doing the 4th root. So we're going to use our 4th powers on our table, and 625 is a perfect 4th root. So if we go over, that's going to be 5. So if we take the 4th root of 625, that equals 5. Now, if we have the 4th root of x to the 4th, it's like taking the square root of x squared. They have the same powers, they can be canceled. So this is going to cancel out, and I'm left with 5x. All right, moving on to example number 2. For example number 2, we're going to talk about cube roots. So we're going to want to look under our perfect cubes. Now, 64, if we look, is a perfect cube, so we can break that down. The cube root of 64 times, now they can only cancel if it's y to the third. Well, we can break y to the 6 down into 2 sets of y to the third. So I'm going to take the cube root of y to the third and the cube root of y to the third, because I can break those apart, because 3 plus 3 equals 6. So here the cube root of 64 is 4. These are going to cancel, so I'm going to get y times y. And I can simplify this. Y times y is y squared, so I get 4y squared. All right, I have 2 more examples for you and we are done. So here's 2 more examples with variables. So now we're looking under the 5th power, so go over to your 5th powers. If you can see, 4 is too small to work for our 5th power, so it's not going to have any that go into it. So I'm going to have the 5th power of 4, okay? Now I need to break down a. If I break down a, well, 10 can be broken into 5 twice. So I'm going to have the 5th power of a to the 5th and the 5th power of a to the 5th. Now I have to do the same thing for b. b is the 6th power. Well, I can get a 5 out of that. So I can say the 5th power b to the 5. But if I take 5 out of there, I still have 1 left. So then I have to take the 5th power of b to the 1st. Now when I go through and simplify, this right here cannot be simplified, and this one right here cannot be simplified. These 3 can be. So these are going to cancel, cancel, cancel. So I'm going to be left with a times b times the 5th root, and I can put these 2 together, 4b. I can simplify this. A times a is going to be a squared times b times the 5th root of 4b. And that will be our answer, ladies and gentlemen. All right, let's come over here to our last example. We have to break down the square root of 40 and x to the 5th. So square root, we're going to be working with perfect squares. So if I want to break this down, another way to do it other than this way is if we can break it into ones that work and ones that don't work. So what's a perfect square that goes into 40, which we've already done before, so that's 4. So 4 times 10. Now we can break down our x to the 5th. So we need x squares in order to cancel. Well, out of 5, I can get 2x squared, so those work. So that gives me x to the 4th. I have 1 left over, so those won't cancel, so I can put it over here with the ones that don't work. When I go through and simplify this, the square root of 4 is 2. These will cancel out, so I get x times the square root of 10x. And now I can combine these 2. So I get 2x squared times the square root of 10x. And that is going to be our answer, ladies and gentlemen. All right, there's some examples for you. That's all I have. Have a great, fabulous, spectacular day, and I will be seeing you soon. Bye.